What we're going to talk about here is the actual definition of a strategy. And so given a normal form game and given a particular player, if that player has a action set A, which contains all the options they have, a strategy is going to map information to what they choose from that action set. And the formal definition is a strategy for a player with action set A is a probability distribution. It's a probability distribution over elements of A. And typically, the way we will denote that is by having a vector sigma of probabilities, so of elements of real numbers between 0 and 1, that is the size of A, such that the sum of all elements of sigma is 1. And that's a bit of a mouthful there, but essentially we say that a strategy in a normal form game is a vector that maps every element of A to a probability of that element being picked. So I'm going to illustrate that with some examples here. And if we consider the normal form game of rock, paper, scissors, where our elements are exactly that, they are rock, paper, and scissors. If we had the strategy that says always choose paper, so if we said our strategy is always paper, then what we would have is sigma equals, now sigma is going to be a vector of size 3 because there are 3 things in our action set: rock, paper, and scissors. And these things are going to correspond to the probability of picking rock, paper, and scissors. So always paper means, oh, that's a 0. And then we can have another one, which is what is the probability of randomly choosing between rock and paper? So 50% rock and 50% paper. That should be probably a comma or something like that. And that would be sigma equals a half, and 0. And so those are the examples of strategies, and the actual definition is the important one. A strategy is something that loosely maps information to action set, to probability, to choices of actions. And in that particular case, for now, they're going to be vectors that represent probability distributions.